Last section of chapter 4 today. This whole chapter has been polynomials. Doing different things with polynomials. We're solving and graphing and doing those, and we're actually going to do both of those things today. But we're going to do it with inequalities, and a lot of the work that we've been doing is going to be very similar again here. But what we're going to be looking for today, and we'll see some rational functions again today as well, is where is the graph a certain value, okay? And that's why we have to pay attention to the inequality that's being used. So the first thing I'm going to do here is I'm going to give you a function. X squared plus 2x minus 15 is my function. And I'm going to try to keep, I'm not going to get into too big and crazy functions, so we'll keep the functions pretty straightforward today, which will be a good thing. On this one, and you're going to see some different questions being asked today, but on this one I'm going to ask you three things, okay? Where is this function equal to 0? Where is this function less than or equal to 0? And where is this function greater than or equal to 0? And so typically what we would do here, and to solve part A, is we have a quadratic equation, which we've seen a lot of over the last month or so. All that part A is asking us is solve the quadratic equation for x, right? What value of x makes this equation function equal 0? And there's a couple different ways that we could do that. We could do the quadratic formula if we really wanted to, but probably not, right? That'd be kind of like our last resort. We could graph it. Graphing it wouldn't be a bad option here. Factoring it wouldn't be a bad option as well. If we could factor it, we could probably factor it fairly quickly in this case. It's not slide and divide or anything like that. So on this one, we could do x plus 5, and we could do x minus 3. And those would be my two factors. If I set both of those equal to 0, I get x equals negative 5, and I get x equals 3. Okay, and as we know, like if we were to graph this, this polynomial, this parabola is going to open up, and it's going to cross the x-axis at negative 5 and 3. And you don't have to get real crazy with your graph here. I'm just doing kind of a sketch and kind of showing you what it's going to look like. And you can put it in the calculator, and maybe that would even be your first step other than factoring, and that would be fine as well. We just really need to solve. And when it says equals 0, what values of x make this equal 0? Those would be my two solutions. X equals negative 5 and x equals 3. And I can always take those two numbers, I can plug it back in and verify that they make it equal 0, okay? And that's something that we've been doing a lot of, a little bit in this chapter, but also in the last chapter as well. Okay, now here's the part that's going to be different. The main topic for today is inequalities. And so now we take the same function, and we want to know when is it less than or equal to 0, okay? And the reason I draw the graph here is the graph is going to kind of help us to determine where is this going to be negative versus where is it going to be positive. Okay, and the value that we're looking about here is in relationship to the x-axis. Because here my y value is 0, and that's where this function is equal to 0. If it's above the x-axis, it's going to be positive. That's where my y values are positive, greater than or equal to 0. If it's below the x-axis, it would be negative. So the first one that I'm asking you is, where is it less than or equal to 0? So as I move along this graph, here's the first place that it's equal to 0. So at -5, it's equal to, and then here's where it drops below the x-axis, and it stays below the x-axis until I get over to 3. So it will be less than or equal to 0, and this is where we're going to use our interval notation again. Anytime we use inequalities, we'll almost always use our interval notation. And we're going to use brackets here because this is equal to. Where is it less than or equal to 0? And then for the last one, we're going to use the same graph. We're going to just keep using the same graph over and over again. And you won't have to do all 3 parts in every single question. A lot of these problems, it's just going to be one or the other. Where is this graph greater than or equal to 0? Well, right here, it's positive, so it's above the x-axis. And then it goes negative, and then it goes back to positive. Okay, so it's going to be positive on this and this part over here. So 2 separate parts. And when we write our interval notation here, we would say negative infinity all the way to -5. Once again, we would put a bracket at -5 because we're including -5 because it's equal to. And then we're going to put a little U symbol, linking those together. And then it's going to start over again at 3. And it goes above the x-axis from 3 to the right forever. Okay, and that would be our answer. Okay, those are the 3 different parts. So where is it equal to 0, where is it positive, or where is it negative are really the parts that we're looking for here. Okay. So that was all 3 parts to it. I just wanted to show you kind of how it breaks up. Not all of them are going to have it like that. Most of the problems that we're going to see are going to just be written like this, and they're going to give us one of the inequality symbols, either less than or greater than or less than or equal to or greater than or equal to, one of those 4. And we're going to solve this, okay? And I don't really care how you solve it today. You can graph it. Graphing it's a great option, okay? The only bad thing about graphing is that sometimes my answers are decimals or fractions, but if it factors nicely, like this one here, could factor into x plus 2 and x minus 1. But we could also just go right to our calculator. Here are the 2 places that it should cross the x-axis. That is greater than 0. Okay, so you got to really pay attention to your symbol today. That's going to be everything about the problem. And so we said everything to the left of -2. This time, though, I'm not going to use a bracket. I'm going to use a parenthesis because we're not including it. There's no equal to sign attached with the greater than symbol, right? It's just greater than. We don't want to know when does it equal. We just want to know when is it bigger or positive. And then it goes to the right of 1. Everything to the right of 1. And so I probably would encourage graphing it, because graphing it gives you a great visual of where the graph is positive or negative. If the graph opens down, then that's going to be a completely different scenario. And so just looking at the graph, asking yourself, when is that graph positive or negative based on whatever symbol I'm given. Okay, here's another one. And I've only given you quadratics, and we're going to see a lot of quadratics. I'll show you a few other things that we're going to see today as well. It's kind of like when we do a quadratic equation or any type of polynomial, we always want to set it equal to 0 first. So this one is not all by itself. So I got to move the 9 over. So this is asking me, where is this graph less than or equal to 0? When is this function? Well, once again, this is DOPS. Not all of these today are going to factor, but if they can factor, all that really kind of does is tell me where is it going to cross the x-axis, because that's going to be a really important piece for what we do today. You can also tell that from your graph. So if you were to type this into your calculator, -3, +3, it's going to open up it's going to give me a graph kind of like that. Okay, I'm just doing a real quick sketch because that's all we really need for today. It's not like yesterday where we had to be a little bit more exact. X-intercepts are the big thing though today. Where does it cross the x-axis? Okay, the second thing that's really important today is, what is my symbol? Less than or equal to 0. When is this graph less than or equal to 0? Well, right here, it's positive, right? It's above the x-axis. And you could even like label this, kind of like we used to do with like increasing and decreasing. Here it's positive, right? Down here it's negative, and then up here it goes positive again. So if it helps you to label it and say, okay, here's positive, here's negative, and that's what we're looking for, is where is it negative, when is it less than or equal to 0? And that's the other reason why we wanted to move this over. We're just going to compare it to 0. At -3 is the first place it's equal to, and then it stays below the x-axis until I get over to 3. What kind of symbols are we going to use here? Brackets, okay? Because we have equal to. So we're going to go -3 to +3, including both of those. And that would be our graph. That'd be our answer. All right, this is going to be kind of like the first one that I gave you, except we're not going to do all 3 parts. And the only one I'm going to ask you to do here is, when is this function, g of x, less than or equal to 0? Now, this is a different function, right? This is not a quadratic function, so it's a little bit different. It's a little bit more difficult. But this is what we did yesterday. This is the type of graph that we did yesterday, so that's why what we did yesterday will tie in a little bit to what we do today. The real big thing that you need to identify here is the denominator, okay? That x plus 4, if you remember yesterday, that gave me my vertical asymptote. Knowing and identifying where that vertical asymptote is kind of a big deal. So for the vertical asymptote here, we would set x plus 4 equal to 0, and we would say x equals -4. We're going to put that line. That's where the graph is going to approach, okay? And you could also do your y-intercept if you want to here, and do all of those things that we talked about. But I'm just going to use the graph here to kind of help me identify what we need here. Okay, so first of all, let's put this into our calculator. Is less than or equal to 0. So when is that graph negative? If I just did a real quick sketch here. This is a really big point, x equals 2. So the only place that this graph is negative or below the x-axis is to the right of -4 until I get to 2. Okay. and we have an equal to sign here. So we're going to include 2, because that's the only place where it would be equal to 0. So our answer here would be everything to the right of -4. We're not going to put a bracket because we can't include -4. -4 is an asymptote. It's never going to hit or touch -4. And it's going to keep negative until I get to 2, and that would be a bracket. If I happened to give you this function, where is this g of x greater than 0, then where would it be positive? Well, it's positive to the left of -4 the whole time. So we would say negative infinity up to -4. Okay, and then it goes to the right of -4. Okay, and it stays negative until it gets to 2, and then after 2, it goes positive again, right? And so then we're going to put this little symbol in here, and we're going to say everything to the right of 2 to infinity. That's why the inequality is so important, right? These are 2 completely different answers based on if we're talking about positive or negative values. And then you got to worry about the plus or the equal to sign as well. Okay, questions on that one? Okay, kind of makes sense using the graphs that we did yesterday. Hey, x squared plus 4 kind of looks like DOPS, but it's not DOPS. Okay, in this case, it's just a regular or quadratic equation that doesn't factor. And so really here, the best way to do this one is just to graph it. And that's why probably my go-to on a lot of these is going to be the graph. Looking at the graph is going to be a great way to be able to look at things today. If I were to graph this one, remembering some of the things that we've done throughout the year or the semester, the plus 4 just tells me I'm going to take that parabola and I'm going to move it up 4. Okay, so it's just a basic old parabola, but the parabola has been moved up 4 units. And so it never does cross the x-axis. And so that's kind of an issue, right? There is no place where this would be equal to 0. And so if I asked you, when is this function greater than 0? So when is this function positive? What would we say? Yeah, all real numbers. You bet. Forever, right? Always. It's always above. If I gave you a different one and said, when is this same function less than 0, when does it drop below the x-axis? Never does. Okay? And so that one would be no solution. Okay. And so those would be ones that you kind of have to watch out for a little bit. Another one that you'd have to watch out for as well would be one of these, where it comes down, hits, and comes back up. Okay? And so if it does that, if it comes down, hits, and comes back up, then this graph, same thing. It never drops below the x-axis. Okay? But it is positive. Okay? And so if I said, when is this greater than 0? It would be greater than 0 everywhere up to this point and to the right of this point. But at this point right here, like let's say this was -5 right here, that would be where it's equal to, not greater than. So if my symbol said greater than or equal to, then it would always be greater than or equal to. If it just said greater than, it would be everything to the left of -5 and to the right of -5, but not at -5, because at -5 it's equal to, not positive or negative. Okay? So that's why you got to really watch out for those x-intercepts. Okay? Those x-intercepts are kind of tricky, especially when you got some different kind of graphs like that. All right, the last thing I'm going to talk about here, fairly short lesson today, at least shorter than yesterday anyway. They use a little bit different wording here, but it's not really any different than things that we've done, okay? But they use the word critical value. Okay? And so if I gave you a function, one over x minus 3 is less than or equal to 0. Very similar to one that we did yesterday. The critical value, if it says what is the critical value, basically a critical value is anything that we cannot have x be. Okay, and so if I said what value of x can x not be here, that would make it a critical value. What value would that be? 3, yeah. So my critical value here would be that x cannot be 3. That's a critical value. And then if I ask you to solve this, then it would be just like all the other ones that we did. We could graph it once again. And we're talking about when is it less than or equal to 0. So we would say everything from negative infinity up to 3. Okay, and I show you this one also because, yes, this does have an equal to sign on it, okay? But is the graph ever going to equal 3? No, because there's an asymptote there, right? So it can't equal 3. So we don't need a bracket on this one, even though there is an equal to sign there. Okay. So that's one thing that could be a little bit confusing. But you just have to think about, can the function equal 3? Like if it has an x-intercept of 3, then it can't. But if it's an asymptote or something like that, then obviously it can. Okay, so I just wanted to make sure if you see the critical value directions, we've done it before. It's just something a little bit different that they call it. Okay. That's all we got. Not too bad for a Friday, huh? Hopefully it wasn't anyway.